Hi everyone, welcome back to the channel. So today we will be discussing another important problem from our DP section. I'll quickly show you the problem statement. So from your SD sheet you can find this problem, form a palindrome. Don't have a look at the code, it will look very simple to you. But let's understand what goes behind this. Let me just check if I'm live. Wait. Okay, we are. So let's move to the problem. What it says is that you are given a string, right? Find the minimum number of characters that you can insert to convert it to a palindrome. Okay, let me take one random example. For example, you know what is a palindrome. We have discussed it earlier. It is nothing but any string which when read from left to right is same as when read from right to left. Okay, for example, this is a palindrome. If I talk about any other string, for example, a b c a, is this a palindrome? So this match, this one matches with this one. B and C are not a match. If I write the string from left to right, it will not match with the string when written from right to left. So this is not a palindrome. If I make it like this, is it a palindrome? Yes. Or if I make it something like this, yeah, I think you pretty much understood what is a palindrome. Now let's understand what can we do in this problem. So if you have a string like this, any string, a random string, for example, you have a c b a. For example, this is a string you have. Okay, first of all, what you need to do here is see, understand, just try to figure out the subsequence which tends to be a palindrome. Okay, so if you observe, can you find, just pick those characters which when fixed together can form a palindrome. Just pick out those characters in order. So what will be those? If I see a, okay, I can pick this a, I can pick this a. Can I pick C also? No. If I pick a, this is going to be a palindrome. Okay, it works. If I pick any other character, will it be a palindrome? What if I include ACA? Yes, this is also a palindrome. What if I make a string like this, ABA? This is also a palindrome. So what you just saw, that we can have multiple subsequences which can be a palindrome. Okay, what we need to think here is that if, for example, keeping what palindrome can be formed, keeping that as it is, let's see how many more insertions. So question is about, sorry, I didn't go on what this question is about. So the question is about how many minimum characters you'll need to insert so that the whole string becomes a palindrome. That's what you need to do in this question. Okay, I'll just check if the internet speed is fine today. Give me a moment. It's lagging. Let me know if it still lags for you all. I think it is lagging. Let's see. No worries. Okay, so how many minimum insertions would be needed? What we just saw, that there are few subsequences which are already a palindrome if we pick them up like this. Now if I check about non-palindromes, for example, if I consider triple A as my palindrome, how many more insertions I might need? So if I talk about this C, AAA, this is already a palindrome. So if I want this entire string to be a palindrome, what I would need is, I will need one more C to be added. Now where can I add this C? So what if you already have this A matching with this A? This A was the middle one. Okay, so if I check about this C, if I insert it anywhere, somewhere here, let's say, will it be a palindrome? Right now what I have is AAC BCA. What I observe is that AAC and AAC CA turns out to be a palindrome. Any more insertions would I need? Yes. If you observe closely, ACBCA itself has become a palindrome. Now you just need one more insertion, that is you can insert one more A anywhere here, let's say here. Now this entire string becomes a palindrome. So what we just did, you might be confused, but one more example and you'll understand what we just did. So basically for this particular string, how many insertions you made? Remember we made 2 insertions, right? Let's take one more example. If I consider in the same problem, for example, triple A, CBA was my problem. And let's say I was assuming that ABA is a palindrome, right? So how many new insertions I might need to make here? So if I take A is matching with A, B was the middle one for it. This A needs one more A to be matched. So let's insert one A here. I inserted one A here. Now this AA and these AA are palindromes. This C, if I see, what do I have in middle? I have C and B. Can I do something? I have done this so far. A, it becomes AA, C, B, AA, right? I have 2 more characters. What should I do in this case? Let's say, what was it? A, B, A. We were considering, I think, what was it? A, A, C, one second, A, C, B, A. So, we were taking A, B, A into consideration. Okay. Now, one insertion has already been made. How many more insertions can you make here to make it a palindrome? If you see, this is a palindrome, this is a palindrome. Now this is the only string which needs to be fixed. If I make one more insertion, that is, if I make C, write C here, will it still be a palindrome? Let's check. A, C, B, C, A. So A match, C match, B is the middle one. So in all the cases, no matter whichever palindrome you are considering for yourself, what did you observe? One insertion plus one more insertion. Total 2 insertions were made here. So no matter whichever palindrome you consider, the thing here to note is that the number of characters which are left, which are not part of your current palindrome subsequence. For example, if you were considering A, B, A as your palindromic subsequence, A, B, A, right? So what were the characters that were left? So number of characters left were 2. So you observe that in all the cases you needed to insert how many characters? 2 characters, and this is the minimum count of characters that you can insert in order for it to be a palindrome. Tell me one thing, what could be the maximum count in case if this question was not about inserting minimum number of characters? What is the maximum characters you can insert? Obviously the length of the string itself. If for example I am given a string AB, I want to make it a palindrome. The direct thing that I can do is that you append the string with the same string, right? Just that in reverse order. So what you'll get, append AB with BA. So you got a palindrome here. So the easiest and the quickest way to, not quickest, the easiest way to get a string converted to a palindrome by inserting some characters would be equivalent to the length of that string. But you see that this is the maximum that we can do. And I want to reduce this count. What could have been done? So although for this question maximum and minimum both are going to be 2 only, right? But for other bigger strings like we just saw here, the maximum would be that I just append the same string in the reverse order. So that would be the length of 5, right? And we reduce this length, the insertions, to 2. So now you see what is the difference and how we need to do it. Now this was one observation, right? One observation was that you figure out the longest palindromic subsequence, right? Okay, you figure out what is the length of your longest palindromic subsequence. Okay, once you know the length of that palindromic subsequence, you know the length of your string n minus whatever will be the length of your longest palindromic subsequence. For example, that is x. You will subtract that count, right? And that's the count of the remaining elements in your string. That's exactly how many insertions you will need to make it a palindrome, and that will be the minimum number of insertions. You got this point? So the point is you have a string of length n. Okay, somehow this is the first thing. Second thing, somehow you make an observation. The observation is that you find out the length of longest palindromic subsequence in that string. Longest palindromic subsequence in that string. Okay. Once you, let's say that is x. For example, that length is x. Once you know the length of the longest palindromic subsequence in the string, the remaining characters, whatever those will be, that will be the required answer for this question. That is the minimum number of insertions, that is equal to the characters that are left after finding the length of longest palindromic subsequence. And what will be the count of those characters? If your string's length is 3, for example, and you find longest palindromic subsequence to be 2, so basically you got only one insertion that will be needed to make that a palindrome. So the answer would be, you need to return n minus x. That's what you need to do, right? We divided into, the tasks are divided into these two parts basically. Actually one part. Now the thing is, you know, you don't have to do anything here. You don't have to do anything here. You just have to write a return statement. The question now revolves around this second step. How to find the length of longest palindromic subsequence. Length of longest palindromic subsequence. Now the question comes down to solving this question. So if you take any string, for example, if I take A, B, C, A, right? So for this, you already know the answer would be 2. Why? Because the length of longest palindromic subsequence is 2 and the remaining characters are 2, so answer will also be 2. Let me do one more thing. Let me make it A, B, C, A. Okay, for example, this is your string. Again, I am doing the same thing. A, B, A, A. Okay. For example, I am giving you a string A, B, A, A. Guys, I'll try to fix this thing tomorrow. I don't know why so much lag is happening. Although I have tried to fix this thing also. And let me check what is the speed right now. Wait. Yeah. Speed is good, but bandwidth might be the issue. Is it still lagging? I'll have to fix this thing. It's lagging a lot, probably. Yeah. Okay. Hope you just don't focus on my video getting lagged, because I think what I'm writing is in place and you can hear me without lag. So yeah. Okay. For example, you have a string like this. Now tell me what will be the length of the longest palindromic subsequence here. You clearly can see A, A, A. So you got a length of 3, right? So what do you need to return? The length of the string is 4. 4 minus what length you got from here, 3, that is 1. So basically your answer is 1. If you insert one more be this entire string, sorry, not here. If you insert one more B, where can I insert that B? I can insert that B here. Your entire string will become a palindrome. But we don't have to tell where to insert. We just have to tell the minimum amount of insertions. Okay, fine. So now how do you find the length of longest palindromic subsequence? Tell me this thing. Are you going to go at every character from beginning and from the end, match with them with each other and try to figure out if this is the longest palindrome so far? No, we are not going to do that. Since we have already discussed problem like this, we are going to go DP way. DP way would be what? See guys, if I reverse this string, another observation number 2 for this question. Why this question has been labeled as hard? Just because of very good observations that lead you towards a solution. So now when the question comes down to this, in this also there is one more observation to do it in efficient way. If I reverse my string and write here, if I reverse it, what will it become? It will become A, A, B, A. Now tell me one thing. you got two strings S1 and S2, right? Okay. Can you not find the longest common subsequence in these two strings? And why am I asking you to find the go LCS way? Because these two strings will only have those characters in common which will be the palindrome in this string. So the palindrome in this string was triple A, right? This was your palindrome. If I want to find the longest common subsequence in two strings, and the second string is the reverse of the first string, you see that this is common, this B is also common, this A is also common. No matter, obviously, we found this was one of the palindromes we found, right? AB is also a palindrome, so doesn't matter which palindrome you are finding. So the question is, you have to find the longest common subsequence, right? So can you not find it in these two strings? What is the length of longest common subsequence? We don't have to find the subsequence, we just have to find the length of it. So I'll find AA common, I move ahead. Whenever there's a match, you move both the indexes ahead. Now this is a mismatch, right? This is a mismatch, so you stay here, you ask from the previous one, you move one index ahead and you just compare with the this one being at its own position. Whenever there is a match, you move your indexes. Is it a match? No, it's not a match. You cannot move ahead. Let's move this ahead. Is this a match? Yes, it's a match. So finally, by the end of it, you get a length of 3. But that's not how we are going to do, because every character, if you memorize or if you recall your recursive tree, every character is going to have two options, right? The option, first of all, whenever there is a match, you only got one option, that is you move to the rest of your string and check for the same thing. And whenever there is a mismatch, remember the recursion tree, whenever there is a mismatch, there are two options. Either you stay there and check from the other string if there is a match for the next index, and vice versa, right? So not going into the details of LCS, because you can go through our past video in which we have discussed longest common subsequence, and you should remember how we did it. Now how to find LCS? Simple thing, we have taken a DP, right? A DP of length 1 plus the length of string 1, and same goes for the other. What we have to do, we have to find the longest common subsequence. Let me write it here, A, B, A, B, A, A. Let's do it so you'll understand. A, B, A, A. Now, if you see in the code, the question ultimately, it's still lagging. I'm really sorry about this, guys. I tried to fix this from the service provider of this internet also, but didn't work. Give me today's time, by tomorrow I'll get it fixed again. Hopefully it works after that. Okay. So what is it about? Now you're just simply iterating over the two strings that you got. One is the string S, other one is the reverse of the string S, right? You're taking a DP of length, number of rows and columns will be 1 greater than the length of your current string. Okay, so simple thing. Now whenever there is a match, you go ahead and iterate over. Let me take it. Let's do one iteration and you will understand. See, what are we going to do? I'll show you. Will keep filling. For example, if this was my string, right? Okay, I am starting from I equal to 1 and j equal to 1. Fine. Okay, what am I checking? Whenever there is a match, it's a match, right? So do you need any insertions there? Whenever there is a match, you don't need any insertion. You simply will ask what is the value present in your DP at what index, I minus 1 and j minus 1, right? So since this is an empty one, right, initially it will be 0. It's a match, you just go ahead and check. Okay, we have to check here longest common subsequence. You already found a match AA, so you already got a subsequence of length 1, right? And if it's a match, you go ahead and ask from your diagonally previous cell, which tells you in this case that what was the length of longest common subsequence in two strings, in which one string is an empty string and other one is also an empty string. No common character in empty substring, so you have already by default have 0 here. You just add 1 for yourself in that answer for one match. Okay, move ahead. Your J comes here, I is still at 1. Is A B a match? So what each cell in this? So I am literally repeating LCS problem again, but I'm just doing one iteration for you so that you can recall. So what does any cell represent? So if I talk about this cell represents that length of longest common subsequences in the strings A and string AB. So if these are your two strings, what will be the length of longest common subsequence? So A and B are not a match, so I will ask, okay, and rest of whichever are empty, you will take them as, assume them as 0, because they will be 0. So whenever there is a mismatch, I will check what was the length I got if from my string, if A was not part of it. So I'll ask I minus 1 J, what is your length? It's 0. And if I include this, right, and exclude B, I'll ask what was your length, that is at I J minus 1. So it says 1. So basically whenever there is a mismatch, there are two options. You got A and AB. A did not match with B. So you will go ahead and ask, okay, A and A, tell me what was the length of LCS for you, that is if I do not include B. And other cases you ask empty string with AB, what was the length of longest common subsequence when you were there. So I'll pick the maximum of these two answers. Whatever will be the maximum, I'll store that answer in this cell. So out of 0 and 1, your maximum is 1. So repeat the same process. A and A are a match, so you go diagonally above and check what is the answer, add 1 to it. So this is 0, so you add 1 to it. And then for AA, it's a match again. So this is what AA, so A and A are a match again. So what will be the answer? You go to the diagonal, add 1 for yourself. So this cell basically represents what is the LCS between A and AB AA. If these are your two strings, the length of longest common subsequence will be just 1. So that's why the answer is 1 here. Let's try to fill up for the rest of the elements as well. Okay, so this will be by default 0. Okay, let's do for it. A and B are not a match, so you check diagonally here, your answer is going to be 0. B and B are a match, right? So you add 1 to this, so your answer will become 2. And you see AB and AB, 2. Now B and A not a match, so you take the maximum of these two. 2 is your answer. B and A are not a match, maximum 2. Now come here, A and A match, so you add 1 to it. Okay, diagonal above. A and B are not a match, so you take maximum of these two, that is 1. A and A are a match, so you add 1 to this and it will become 3, right? A and A are a match again, so you add 1 to this and it becomes 3. Okay, and you'll map, if you can map also how we are getting 3. You'll see that in ABA and ABA itself is the longest common subsequence. That's what you're going to get. For this, AA is a match, right? So you add 1 to it. AB is not a match, so maximum is 1. AA is a match, so you add 1 to it, becomes 2. AA are a match, so you add 1 to it, becomes 4, right? So should our answer be 4 only? If I talk about AB, I think I made a mistake. I'm sorry, this should have been reverse of it, AABA. So I'll change my answer accordingly. I went with the flow and just did for that, but I hope you understood. For this, the answer would be 3 only, and if I want to change it, I will. It will take a little bit more time. Let's quickly do it. AA is 1, AB 1. Although the problem is solved, I'm sure you already understood the question AABA. If you want, I'll quickly do it for you. So 0, 0, 0, 0, 0. Okay. For AA, it's a match 1. AB, it's not a match 1. AA is a match 1. AA is a match 1. For A A is a match 1, AB is not a match 1, AA is a match 1 plus 1 2, AA is a match 1 plus 1 2, BA not a match 1, sorry 0, because you will take from here and here. BB is a match 1 plus 1 2, BA is not a match, so maximum is 2, and BA is not a match, maximum is 2. AA is a match, so maximum will be 1, means you add 1 to it. AB is not a match, maximum is 1. A is a match, 2 plus 1 3. AA is a match, 2 plus 1 3. Finally you got 3 in this cell. This cell represents the longest common subsequence in ABAA and AABA, right? So once you got this answer as 3, you know the minimum insertions would be the length of your string 4 minus LCS of what you calculated, and this answer came out to be 3. So finally your answer will be 1, and that's all about this question. So time complexity, again it's n square, that is the length of your string, and that's all about this question. Nothing more to explain here, right? So fine then guys, that was all for today, and we will now wrap it up. In case you have any doubts, you can write in the chat. If not, I will just wrap it up and see you all in the next lecture. Fine, I'll fix this lagging issue. I'll try in the next session. It doesn't come along. Fine. Okay then, bye bye.